Hello and welcome to another tutorial on dev.java website, and we are looking at the creating variables and naming them. And we said that everything in Java is classes, right? So the scope of variables is always about the scope of a class, and the variables are associated with the class or called the class variables, or in Java we call them fields. In C++ we call them member variables. These can be either non-static fields. These are related to the state of a particular instance of the object. So different instances of the class can hold different states, right? They can hold different data. So non-static fields are the ones that define the state of an object. An object is an instance of a class. Static fields are the ones that define the state of the class itself. These are not associated with the state of a particular instance of the class. These are defining the state of the class by itself without any need for instantiation. And static fields are shared amongst all the instances of a class. So if one instance changes one static field, the other instances immediately see that change. But there is another type of variable which is not related to the state of a class, right? So it's about local variables, and we talked about this when we talked about scoping. We said that you can define a scope in Java using a pair of curly brackets, and the local variables are defined within the closest scope that they are defined into. So if I create a new class, for example, let's call it local variables, and let's have a main method. Now outside the main method, so if I remove this main method, I have an empty class, which means right now, first of all, I cannot write anything outside the scope of the class. I cannot say AA outside the scope of the class, right? Anything in Java has to be inside the scope of a class, right? So we have to type something within these pair of curly brackets. And let's say I type AA. Let's also indent it properly. So AA. So what happened here is that we defined now a class variable or a member variable, and we said that in Java we don't use the term member variable, we use a field, right? So F-E-I-L-D, field, right? Field, F-I-E-L-D. And this is called an instance field or a non-static field. So this is called an instance variable. Instead of member variable, we say that it's an instance variable. The reason that we don't use the word member variable, the word member, because everything has to be part of a class. So it's not like C++ that you can define variables or something outside the scope of a class. In Java, everything has to be defined in the scope of a class, right? Now, if you look at the annotation here, you see that it's a triangle, which means its access modifier is package level access, which means we're not specifying any restriction here. When you don't explicitly provide an access modifier like public, private, protected, it means this is only accessible to the other classes in the same package. And this is the concept of friend keyword that we have in C++. In Java, we don't have the friend keyword, but it's implicit that whenever you don't explicitly define or restrict access to the variable, it's a package level access. So any class in a package is automatically friend to all the classes in the same package. So that's the definition of or the implication of the friend or friendship in Java. In Java, any class in the same package is a friend. In the same package is a friend to this class. In C++, you have to define the friend and say that, for example, in C++, if you want to say that another class is a friend of this class, you can say friend class, for example, class, for example. What happens here is that it means that if another class of this type can get access to all the internals of this class, these are friends. Now in Java we don't do that. Instead we say that everything inside the package is a friend unless we manually override that default behavior using a private keyword, right? So if you private means this variable can never be accessed physically outside the scope of this class. So that's the restriction about private, right? So we haven't talked about the access modifiers yet, but So we said that, okay, variables have to be defined without the curly brackets that define the scope of a class, right? So we define this. There is another way of defining a variable in the scope of the class, which is, say, we use the word static, right? Static double B. And now the difference here is that this is an instance variable. A static double B, this is a class variable, or we call them static fields. Again, in Java, we use the terminology field. Okay. And Eclipse properly italicizes the static variables. And we said that the way you access these static variables, you don't typically access this via a reference to a particular instance of the class. You just access it directly via the class name. So you say local variables is a class name .b, for example, right? And the other restriction is that obviously a class, not only it can hold data, it can also hold behavior, which means methods. We have the same category here, member functions. In C++, we call them member functions. In Java, we call them methods, and they are non-static methods. So fields and methods, right? Fields are data, methods are behavior that act on those data. And then we can have a non-static method and a static method. A static method cannot access non-static fields. So anything inside a static method must be related to static variables, static fields. And makes sense because static methods means they're not associated with the state of a particular instance of the object. So they cannot really access the data that are associated with a particular instance, right? So eventually, later on, we look at the static methods and instance methods or instance fields, right? Or instance methods or non-static methods. Non-static methods. So these are defining the behavior of the class. In object-oriented terminology, we have data. So fields are data and methods are behavior. Now, there is another way to write a variable here. I can create an artificial scope. As you can see, I just created a scope. And note that what Eclipse did. Eclipse created a private with this curly brackets ... This is called a non-static initializer or instance initializer. This is called an instance initializer. Instance initializer. Now, for example, I can initialize a here 2.5, right? And Eclipse knows that this is a this a is the field. But then I can define another variable here. Double C is 5, right? Now, what is this C? First of all, where is the scope of this C? And so maybe it's better to actually make it more confusing by defining it as A. And this is perfectly allowed. We have a warning here. This warning is related that this variable has never been used. And your question might be, how come we have defined A here in the scope of the class, but then we are redefining another variable with the name A? But it is allowed. So there is no name collision. Why? Because this is considered a local variable inside this instance initializer. And the scope of a local variable, the scope is limited to the closest scope, and the closest scope for this variable is this pair of curly brackets. It's not this pair. It's not the pair of the curly brackets that define the scope of the class, right? And therefore there is no name collision. When we define this variable only exists within the scope. As soon as we get out, we cannot access this. So the compiler doesn't complain because it's very clear for the compiler what this variable is, and it's very clear for the compiler that this variable A is not this field A, right? Because this is within this scope, so the compiler assumes that this is a separate variable. So local variables are different from fields, static, non-static fields, because they're not associated with the state of the object. They're just temporary variables that we use to hold the results of some data or something. And maybe later on we try to assign this, let's say we try to define this and then maybe do some math calculations, double it and assign it to the state of the object. So obviously if I say A equals A times 2, both of these A's are this local variable, because that's the closest scope that the compiler can confer. If I want to say I want to this A on this right on the left hand side to be actually the A, that is the field of this class, I have to use the pointer of this and explicitly tell the Java compiler, hey, this A is actually this related to the state of the object. And the way you access the fields of an object, the instance fields, non-static fields, is using the this keyword. So this way you are basically removing, this is called shadowing, right? Shadowing, which means if you have local variables that have the same name as the field, or global variables or the state variables of the class, they can shadow if the name is the same, because the compiler always infer them based on the closest scope. So, but the this keyword here demystifies or makes it very clear to the compiler what your intent is. Now, obviously, we can do the opposite. We can say A equals this dot A times 2. Now, I haven't initialized A, but we know that when the JVM loads this class in the memory, every field gets initialized. So a double gets initialized to 0.0, right? So the default value of A is going to be 0.0. Or you can see 0D, capital T, or small d. This is mean double, right? I usually use the floating point notation, which is the default is double in Java. So as you can see now, this A on the left hand side is the local variable, and the one on the right hand side is basically qualified with the this pointer, which means that now this one is actually the field, right? Again, this is because the names collide, right? Name collision and the shadowing name collision. That happens, and we want to prevent that, so you have to qualify these with the this keyword, which means that now this A variable is actually associated with the state of this class, this object. What this tells the compiler, hey, go look for this A outside this scope of these curly brackets and inside the scope of the this class. So this means look for this variable in the scope of the class. And obviously local variable doesn't exist outside the scope of its outside its closest scope. That's why when the compiler goes and searches for a variable name A outside this blue region, it finds this one. Now obviously you cannot have like a float A again. You cannot have two variables with the same name, different types with the same name in the same scope. Both of these are in the same scope, so the compiler doesn't allow that because that's name collision and that's ambiguous. So I hope you really get a good grasp on this. Again, in C++, this scoping becomes more important because objects, especially when you're dealing with objects, because they have destructors, and this scoping allows you to exactly know when the destructor is going to be called, especially the objects that you create on the stack. In Java, you don't care about those stuff. The subtle difference with the this keyword between Java and C++ is in Java, this refers to a reference to an object, and any reference, using a reference to an object, we use the dot operator to access the fields and methods. In C++, this is actually a pointer, which means you use the arrow operator, right? So if you want to access A, you have to say this arrow A. What this means is that this is a pointer. Go to the address, memory address that this pointer points to, and then read the value and assign it. And the equivalent thing in C++ is that you have to first of all dereference the pointer to get the actual value, and then call the dot operator. Now, obviously Java was designed to be easier and remove the concept of pointers. So, but I'm happy that they kept this similarity, that okay, this is a reference instead of pointer, so you no need to explicitly like dereference it, because whenever you have a pointer, you have to dereference it to get a reference to the object, and then use a dot operator. But this is in Java is hidden from you. Dereferencing of these pointers are hidden, and the JVM automatically does that, and that makes code more readable and easier. Sometimes you have lots of these stars. One of them is multiplication, one of them is dereferencing, so it just makes the code less readable. So they remove this kind of complexities in Java. So local variables, similar to how an object stores in its states in fields, non-static fields, and then a class, the state of a class is a static fields. The state of an object, which is an instance of a class, is the non-static fields. A method will often store its temporary state in local variables. So again, same, we use an instance initializer, and this has some use cases. I'm not going to go into the details of the instance initializer and static initializers, etc. But methods are the same. Let's say we define a non-static method. Let's say public void public void set A, for example, and double A. Now, I mean, the convention is that in Java we use, for the name of the variable, for setters we use the same name as the fields, and I already told you how to prevent the name collision and make it to, for the compiler, what the variables are. So if you want to assign this local variable A, know that the scope of the parameters are also the scope of the method, and parameters are also on the other bullet point here. So we have these parameters, but then we can also define another variable here, let's say 2.5. So this B here is also a local variable, and its scope is limited to the scope of the method. Again, a scope is anything that is between a pair of curly brackets. So languages like C++, C, or Java, they use the curly brackets to define the scope, right? And the nice thing about Eclipse and the coloring theme is that it tells you exactly, when you just look at your code, Eclipse gives you a very nice visual cue of what is the type of this local variable, what is the type of this variable. Any brown variable, it's a local variable, and if you never use it, Eclipse automatically gives a warning that, hey, you're defining a local variable, you never used it, so what's the point of defining it, right? And obviously when you run your application, the JIT compiler, if it tries to optimize the code, it just removes this. Similar in C++. So if C++, if in C++ you write a code like this and then set the compiler optimization to the maximum, I mean, you don't see this in the assembly code. This compiler just removes this because it says, okay, you never use this variable, there is no point of defining it because it's a local variable. Now obviously that's not the case if you use the global variable or a class variable. So let's say we want to set A, so we say this.a equals A. Again, we cannot say A equals A because A here is a local variable. It's a parameter, but the scope of the parameter is the same as the scope of the method. And A equals A, both of them are inferred to be the variables in the closest scope. That's how the compiler searches for variables. It looks into the closest scope. If the compiler cannot find, then it goes to the outer scope. For local variable, the compiler never goes out of the scope. So we have to explicitly tell the compiler, hey, this A variable, go look for this in the scope of this class, not the scope of this method, because the scope of the method is automatically defined for the local variable, so there is no ambiguity. But here we tell it just jump out of the scope of this method and then go into the scope of the class, which is the pair of curly brackets that define the scope of the class. Now, as I mentioned, similar to local variables, so the syntax for declaring a local variable is similar to declaring a field. Any variable, regardless of if it's a state variable of a class, if it's a field or local variable parameter, anything has to have a type, so the compiler knows how much memory to assign. It has to have a name, and then we typically want to initialize it. If you don't initialize local variables, the compiler will complain. So let's say I define this local variable, but I never initialize it. The compiler basically, and then what happens if I try to say use this variable without initialization? Now there is an error. So if you define a state variables, you don't initialize them, these variables that define the state of a class or object, they will be initialized by JVM. So that's the guarantee that the Java language provides, saying that anything in class associated with a class has to be initialized, because we don't want to have a class loaded into the memory by JVM but having garbage values in the variables. That's something that might happen in C++, and garbage values sometimes create bugs that it's very hard to detect, right? So the Java said, okay, no, we just don't allow garbage values. Whatever you define, we initialize it for you. But here that's not the case for local variables, because it doesn't make sense to go around and initialize every local variable because they might not be even used and the JIT compiler can just remove them. So the rule for local variables is that they have to be initialized before being used, right? That's not the rule for the state variables. Any state variable, you don't need to initialize them and you can immediately use them, right? I can say here a plus this dot a. I never initialize this variable, but this expression this dot a will be evaluated to a correct value, which is the initial value of a. This variable has been initialized by the JVM, and that is initialized to 0. But that's not the case for local variable. Whenever you have a local variable, you have to tell the compiler that you have initialized it before using it. And that's the complaint that the compiler is making. It says that the local variable b may not have been initialized. So local variables, you have to initialize them before using them. So in C++, this code compiles, but then b has some garbage value. In Java, they don't allow you that. So you have to explicitly basically initialize the local variable. Same for objects. So if you have an object type, then the reference is by default is null, so it's not initialized. And obviously, if you try to use it, you get most likely a null pointer exception, or getting this error that you haven't initialized it. Now the solution here is obviously we have to initialize this. We explicitly tell the compiler that, hey, go ahead and assign 2.5 to b before using it. It's a local variable. As soon as we hit the scope, this value b and also this a, these are popped out of the stack. So I'm not going into the details of the internals of the JVM. I will have in-depth lectures on the internals of the JVM, how the stack works for the virtual machine, why it was selected as a 32-bit stack, why that decision was a very bad choice for these days computers, because right now every CPU is 64-bit, so having a 32-bit stack for virtual machine is really not that optimal choice, especially if we are dealing with variables that by default are 64-bit. Then because if the stack doesn't allow in one operation, if it doesn't allow a 64-bit value to be pushed on the stack because the stack is 32-bit, you have to do 2 pushes, and that causes significant problems for multi-threading, multiprocessing. That's why they had to introduce the keywords like volatile, this kind of stuff. And yeah, so these are the topics for more advanced discussions. For now, just remember that any local variable has to be initialized. You have to explicitly initialize it before using it. That's not the case for member variables or fields of a class. Static or non-static doesn't matter. Java language specifications guarantees that every field, anything that describes the state of the object, either the instance fields or static fields, they will be initialized when the class is loaded in the memory. All right, so you can immediately use this and they will have default values. That's not the case for the local variables. All right, let's go ahead and finish this. Local variables, which is between the opening and closing braces of the method. Again, that's a pair of curly braces or curly brackets defines the scope. That's the concept of scoping in Java and C++. As such, local variables are only visible to the methods in which they are declared, right? As soon as you get out of the scope of the method, those local variables are destroyed. They are not accessible from the rest of the class, right? Unless you wrap them into some sort of objects, which usually what we do, like we have a standard pair, for example, in C++, we can create the same thing in Java. Right now we have records. Records are a very nice thing to basically wrap local variables in them and then return them as a method so that we can still access the results of local variables later on. So records are very good, and I believe they eventually allowed let's see if we can return a local variable as a so let's say void test record AA, right? So I believe they eventually allowed, I think it's not allowed in JDK 15, but at some later JDKs they allowed method local references, so method local records. What this means that I can locally define a record, let's say a pair, and then it takes AA, B. Records is not available. Okay, so I have to switch to JDK 17. So So right now, I guess my compiler is set to JDK 15. Let's look at the properties, builders, Java compiler. Right now it says to 15. Let's see if we can set this to 16. And now I guess record is allowed. Let's see what the error here is. Syntax error, insert record body to complete the... All right, so do we need to have a body for the record? Okay, so double A, double B, and then let's say we want to return this pair from this method, and then a pair cannot be resolved to a type. So I think with JDK 15, okay, so let's also change the runtime to JDK 16. Okay, so it's still complaining. Yeah, so you cannot probably basically define a local record, and then we can probably return an object, and then say var p1 is a new pair, and then give it a and 2a, for example, and then return p1. So records are in JDK 16. I set my compiler to JDK 16. I'm changing my runtime from Java 15 to Java 16, and this seems to work. But let's create a main method and actually test it. So let's say we create a var obj1 is local variables, and then we just call the default. We use the new keyword called the default constructor, and then var pair 1 is obj1 test record, double A, let's say 5. So this code seems to work fine. So let's do a sysout on the pair 1. Let's see what we get. And we're getting a pair. So you know that records by default implement the toString in a nice way. And if we say get class, records also provide this functionality for get class. And it's a pair, and as you can see, it's an anonymous class. Anything that any class that is some sort of inner class, which means it's not in a global scope of a source file, Java file. And this record is a class, but it's not defined in a global scope. It's inner, it's inside some inner scope. It's identified with $, but still it's compiled to a separate class file. But then what is this number one? Number one is appended to the $sign when that is that class, that inner class is a is treated like method local inner class or an anonymous class. So numbering after the $sign, if you see a number, you see that it's some sort of anonymous class, right? So if you define an anonymous class, it compiles to number $1, $2, etc. But this anonymous class has name. Usually anonymous classes don't have a name because they're usually interfaces, and you just provide implementation with the name of the interface. This one is actually a class. Now the question is, can we access the if this is in fact it's a pair, can I access its variables? Right now we can't, because this is referred or inferred as an object. So let's typecast it to pair. And obviously we don't have access to this pair here, right? So the question is, how do we do this? I don't know if it's possible because this is anonymous class. So obviously the best approach is to now the interesting thing is that this compiles, but the question is, how do we access the how do we access the actual data that are inside this record? Let's see if we can call this. This obviously doesn't compile. The method A is undefined. So inside this we can have a p1.a and b. These are private final, and then there are a record has a final field, private, and then two public methods, a and b, that provide direct calls to values, but we don't have access to them. So they decided to allow the construction of the records as anonymous classes or method local classes. But then we don't have, obviously if we return it from the class, then we don't have access to those internals, and we cannot really typecast it because we don't have access to this pair, right? So let's quickly finish this one. Local variables, parameters. Parameters are the variables that are inside the inside this pair of round brackets, and the scope of the parameters are also the scope of the method, right? So these are also considered local variables. And so if you use a variable a here, for example, this is basically this parameter, and if you have other variables with the same name, you have to differentiate the scoping. You've already seen examples of parameters both in bicycle class and the main method of the Hello World application. Recall that signature for the main method, public static void main, and array of strings as name args. These are the command line arguments that are passed to your Java application when you launch JVM. Here the args variable is the parameter to this method, and again this is inferred as a local variable to the scope of the main method. The important thing to remember is that the parameters are always classified as variables and not fields, right? I mean, fields means associated with the state of the object. Parameter of a method has nothing to do with the state of the object. You can use them to update or change the state of the object, but then most of the time you try to also use this disqualifier, use this to differentiate with the naming, right? This applies to other parameter accepting constructs as well, such as constructors and exception handlers that you'll learn about later in the tutorial. Having said that, the remainder of this tutorial uses the following general guidelines when discussing fields and variables. If we are talking about fields in general, excluding local variables and parameters, we may simply say fields. And again, fields means a state of the object. This has to, whenever you hear field in Java, it means a state of the object. We don't say member variable or non-member variable. We just say fields, a static or non-static fields. If the discussion applies to all of the above, we may simply say variables, which means instance variables or static variables. If the context calls for a distinction, we will use specific terms, a static field, local variables, etc. A static fields, it's a static variable that is associated with the state of the class. Local variable, it's a variable that is associated to some scope of a method or something else, right? As appropriate. You may also occasionally see the term member used as well. Again, that's a C++ terminology, like member variable, member function. In Java, instead of member variable, we say field, non-static field or a static field. We just say field. In Java, instead of saying member function, we say just a method. And the whole reason is that in Java, nothing is allowed outside the scope of a class. But in C++, you do have a scope outside to class, which is called the global scope. So you have to make this use of this member. A types, fields, methods, and nested types are all collectively called its members, right? So a class has members, which means fields, methods, etc. The next is naming variables. I leave this for the next tutorial. I hope you really enjoyed this one. Please stay tuned, and I'll see you in the next one.